Okay. So last class we did the probability of two things happening in succession. So, like drawing a king and drawing a queen. That's the multiplication rule. The addition rule is for the word or. So when we have or probabilities, we're going to use the addition rule.
Is this easier or harder?
I don't know. It's all relative.
In your opinion.
Easier. I'll say easier. That's the answer you want, right?
Yeah.
So when we were doing an and, we need to know if the events were independent or dependent. When we're doing an or, we need to know if the events are mutually exclusive or not mutually exclusive. Mutually. Aha, yes. It is a relationship. Math is all about relationships.
I was talking about
It is like back in the day, people used to say, like me and my wife, we're exclusive. Okay, so we are mutually exclusive. We are seeing each other and only each other. So me dating somebody else and being married to my wife cannot happen at the same time.
I mean, not if you want to.
So mutually exclusive events are events that cannot occur at the same time. So when we did and, we were doing two things at separate times. When we're doing or, we want to know if the probability of two things happening at the same time. So if something can't happen at the same time, then they're mutually exclusive events. So if I roll one die, can I roll a 3?
Yes.
Can I roll a 3 and an even number at the same time?
No.
No. Those are two mutually exclusive events. They cannot happen at the same time. If I go to the dealership, can I buy a Toyota and a Ford at the same time? No. Mutually exclusive events. Well, I'm buying one. So I can't buy a Ford and a Toyota. Unless it was a real hoopty, like somebody put a Ford truck bed on a Toyota chest. How about going to the dealership, buying a Ford, and buying a Explorer?
Yes.
Yeah. So those are not mutually exclusive. I can do that all at once. Buy a Ford Explorer. Should I keep going? I'm good? I'll do one more. Rolling a 4 and an even number.
Yes.
Cool. Not mutually exclusive. Awesome.
Rolling with 4
And an even number.
Okay, got
This
it.
4 is even. Blank page. So I will now. So we had a multiplication rule for independent events, and we had a multiplication rule for dependent events. If they're independent, we just multiply the probabilities. If they're dependent, we multiply the probability of the first one by the probability of the second one, given that the first one already happened. Here, for the addition rule, we have one for mutually exclusive events and one for not mutually exclusive events. If the events are mutually exclusive, the probability of A or B is equal to the probability of A plus the probability of B. So you just add the two together. If they're not mutually exclusive, then we will add the two probabilities together. But then because we can have them both at the same time, we have to subtract out the probability. I didn't give myself enough room. We have to subtract out the probability of A and B occurring.
You're in good examples.
Totally.
We're like 2 minutes into this and I'm already so.
You'll be fine. This is abstract a little bit. I'm using A and B. What are A and B? Who knows? Let me give you A's and B's. Two mutually exclusive events. The probability of rolling a 3 or an even. Mutually exclusive. Can't happen at the same time. The probability of rolling a die and getting a 3 or an even number is simply the probability of getting a 3 plus the probability of getting even. So there's 1 3 and there's 3 evens. How's that one? Better?
Yes. Wait. So you're only rolling it once?
Once.
But now 3, 4. Oh, 4.
So
Sorry,
both
okay.
would satisfy this. 3,
Got it.
2, 4, 6. So 4.
Yeah, you should just say it out loud then.
Let's do not mutually exclusive events, rolling a 4 or an even. So I have the probability of rolling a 4 is 1/6. The probability of an even is 3/6. I've counted one number twice. What number did I count twice?
4.
A 4. So I subtract out 1/6.
Okay, why?
Because the 1/6 here for rolling a 4, that probability, and the 3/6 here for rolling an even number, both take into account rolling a 4.
So why did you add 1 6?
They don't always work out this neatly.
Okay.
So how do you calculate it?
Well, the probability that it's a 4 and even is, there's only one way to do that, right?
Oh, okay.
So I end up with still, well, I should say 1/2. Questions? Questions? All right, I need to get a. Okay, so I have data from a sample of 409 people. And from those 409 people, they were asked their blood type and then their RH factor. So I learned yesterday that the RH factor is a specific protein in your blood, and you either have it or you don't. So if you have it, it's positive. If you don't, it's negative. What that means, I don't know. Ask one of our wonderful biology teachers. So let's find some probabilities. I want to find the probability that if I randomly select one of these people, that they have blood type O or A. So first, you must ask yourself, since it's an or, you need to ask yourself, are these mutually exclusive events or are they not mutually exclusive? So they can happen at the same time? They are mutually exclusive because if you have type O, you cannot have type A. So since they're mutually exclusive, we can just find the probability of each and add them together. So my probability of having type O blood is 184 over 409. Probability of having type A is 164 over 409. So if I go and randomly select one of these 409 people, the probability they have type O or type A is... Can you give me a decimal approximation of that? 0.850? So approximately an 85% chance that a randomly selected person from those 409 has type O or type A. Is this, here's a good question. Is this empirical data or theoretical? It's empirical. It was collected. Yeah. No. Let me let you try this. Find the probability that a randomly select person has type B or is Rh negative. Yeah, it is actually.
Sorry. Chick-fil-A, you know. Wait, would you say minus 15?
What's the probability? We can always start with an or by adding these two. So what's the probability I select somebody with type B?
45.
How about RH negative? RH negative? 65 over 409.
So you're gonna add negative.
Okay. Total number of RH negative people. Are they mutually exclusive? No, they're not mutually exclusive because I can be RH negative and have type B blood. So I have to subtract out the people that I counted twice. There are 8 people who had type B and were RH negative. So 8 of these 45 people were counted here in the 65, so I subtract that back out. That's 24.9 or 0.249. Yesterday, I approximated 25%. And somebody helped me with 24. 102 over 409.
Well, I guess it's just
Yeah. I looked at the place where type B and negative met. Those are people who are type B that are also negative. Questions? Okay. Huh?